The first question, okay, most importantly what we have to do is, let me just give me 1 second. Okay, let me just copy this and then try to find out. Okay, can I share both of them? No. ನನಗೆ ಒಂದು ಎಡಿ ಕಿಟ್ ಸೆಟ್ ಫುಲ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಜೊತೆಗೆ, ಅದೇ మేము ಹುಡುಗರಿಗೆ ಏನು ಕೊಡ್ತೀರೋ ಫುಲ್ ಸೆಟ್. Okay, are both of them visible? Hello. Hello. Okay. Now in the first case, it was asked to find what is VD1, VD2. Once you know what is VD1, VD2, you can find what is the output offset voltage. So depending on which is the non-ideal parameter, you are supposed to find the input offset voltage. Is that correct? One of you unmute. So who is there? Ayush Kumar, why don't you unmute? Ayush. Okay, shall we start? Let us go to the second case, because first case most of you could able to do it. The second case, where is the mismatch, man? So there is a mismatch in W by L. So we have W by L of 1 and W by L of 2. Suppose if I write the circuit diagram, so this is the circuit diagram what you have. I'll do it for one of them. You can just do it for the rest of the two. It is minus VSS, and this is, I hope you are writing it, not seeing like a movie. So this is okay. Now M1, M2, this is VD2, this is VD1, this is RD1, RD2. So for the second case, RD1 is equal to RD2 is equal to, now it is 800 ohm. Am I correct, Ayush? V2 is equal to 0.5. Done. But W by L of this is, if you can see, it is 200 divided by 10 micrometer, and this is 300 divided by 10 micrometer. Am I correct? Okay. Now we of course while deriving the expression for the input offset voltage to nullify the output offset voltage, so what did we do? We actually did W by L of 1. Okay, W by L of 1 was equal to W by L plus half of the delta W by L. Correct? W by L of 2 was assumed to be W by L plus, or sorry, minus of half into W by L. Is that fine? I hope this is visible also. Okay, let me just show this only, because anyhow, is this fine? Now the question is, what is this W by L and what is this delta W by L? Correct? So we have W by L of 1 as okay, let us, because L of both of them is same, let us try to find what is W1 and W2, which is already given as 200 micrometer and this as 300 micrometer. Correct? Can we find what is W? So can we just have it as W1 plus W2 by 2, which is equal to 250 micrometer. Now if you take W by L of 1, W by L of 1 as equal to W by L plus half of delta W by L. So what is this W by L? Can I write it as 250 by 10 plus half of if you can actually see this, this is 250. What is this here? 200. Can you see this is 300? Is this 200 less by 50 compared to 250? Is this W2 more by 50 compared to 250? Shall I say now delta W is, or delta W by 2 is equal to 50? Correct? Then what is delta, or what is half of delta W by L? Is it not 5? Then what is delta W by L? Is it not 10? Correct? Now this way we can able to get what is delta W, because you're all engineers, no? Once something like this is given, you find the average of it, which happens to be 250. The W by L average is 25. So how much is this here? This is 20. How much is this here? 30. So how you are getting this 20? It is actually 25 minus 5. This is how we are getting 25 plus 5. So what is this 5 here? Half of delta W, half of delta W by L. Because we are considering the error is symmetrically there. Correct? I don't know, okay, how many of you could any of you could able to reach to this extent? I want to give full marks to that person. Who did? Can you share it? Can you share your answer? I want to give 10 to 15 marks for your T2. I want you to share it. Hey, come on, what is this? I don't. You're not at all trying. That I can clearly see. You are so casual in. No, don't expect everything to be taught in the class, so that I will just take you to the end of your SE and then just drop you there. Okay, now because why you could able to do the first one is because the first one is straightforward. Can you see here? The straightforward, because we have done it so and so. So what was V out here? V out was I by 2 delta RD. Everybody could able to find what is V output. What is this? V output offset voltage and V input offset voltage. Of course, you could also know what is the expression for VDD1. What was the expression for VD1? Here, no, here. In all the cases, it is VDD minus ID into RD1. ID1 into RD1. In all the cases, it is same. But the thing is that in only the first case, it is the RD changing. In the other two cases or three cases, the ID is changing. You have to find out what is that ID. I don't care why, when you people able to wake up and then do it. No, don't. Of course, we expect something from you people also, no. So don't expect everything to be spoon fed. Okay, and whatever is there written in the notes, same thing is asked. Then why? What is the fun in teaching you all these things? So it's not so, man. Engineering means you need to think. That's why I don't know. Okay, yesterday night, how many of you thought of doing something like this? Let me see, one or two of you. Okay, one of you, only one of your friend has Send the things. Okay, that is fine. Okay, ID1, of course. Now Nauda could able to send me that. Okay, ID1 was equal to 800 microampere, and that is 1.2 microampere. That's perfect. I don't know about others. Okay, let us try to find out. Okay, how does this will go? As I said, uh, what is the value of? Okay, what is this? We are done with this. So, what is ID1 is equal to? In general, half Kp W by L VGS minus VTO whole square. Shall I write it like this, or can I write it as half Kp W by L of 1 VOV square? So when I say VOV square, VOV is that voltage which is responsible for getting ID is equal to I by 2. ID is equal to I by 2. So how do I find VOV now? VOV is nothing but under root of 2ID Kp W by L. W by L of 1. So you substitute W by L of 1 as 25, because we are looking for exactly half division of this 2 milliampere has to be divided equally between these two. Done. So what is VOV now? VOV is equal to under root of what is 2 into ID? Is it not simply I? Because ID is equal to I by 2. Done. Is it 2 milliampere divided by 200 micro multiplied by 25? One of you give me the value of VOV. Oh, come on, man. This is 2 ID. What is ID? ID is equal to I by 2. This is 1 milliampere. 1 into 2 is 2 milliampere, no? Okay. All 0.632 volt is the overdrive voltage. Done. Now this is one part. I need to find what is ID1 now. So what is ID1? Okay, I need to substitute W by L of 1 as this expression. So is it not equal to half Kp W by L plus half of delta W by L, or is it plus or minus? It's actually minus, because it is less now. Maybe in the while deriving we would have taken it as plus. It's fine. Okay, it can be either plus or minus. Is it POV square? Shall we write this? Of course, that's what we did in the derivation also. It was Kp W by L VOV square, and then otherwise, okay, we can just take this VOV, sorry, W by L outside. It is 1 minus delta W by L by 2 into W by L, so and so. Is it not I by 2 1 minus delta W by L by 2 W by L? We just defined one term. What is the term? Change in current due to this mismatch. What was the current that would have been flowed in the MOSFET if there was no mismatch in the W by L? 1 milliampere. That's what is this. Correct? You can see this is the change. I by 2 multiplied by change in ID1 due to mismatch. Due to mismatch in W by L is how much? I by 2 multiplied by delta W by L divided by 2 W by L. Correct? Then how much is this quantity now? It is now is it 1 milliampere multiplied by, what is delta W by L? Can you see here? Delta W by L is 10. Delta W by L is 10. So it is 10 by, so it is 2 into W by L. So how much is 2 into W by L? So actually W by L is 25, so it is 50. Done. How much is 5 by 0.2 milliampere? Correct. This is what? change in ID1, change in ID. Done. What is ID1? ID1 is equal to I by 2 minus delta ID. ID2 is I by 2 plus delta ID. Okay? So what is actually I by 2? 1 milliampere. I by 2 is 1 milliampere because I is 2 no. This is I. So it is 1 minus 0.2 is 0.8 milliampere. How much is this? 1.2 milliampere. Okay? Now, is this point clear to all of you? I want the response from each one of you in the chat box. What is, okay, how did I take the W by L as 25? This is more important. So because only what is given is, this is given as 200, that is given as, sorry, this is 200, that is 300 in terms of width. The L is common. So there is a mismatch in the W by L of this and this. So it is, we need to find out what is the mid value and what is the deviation. Mid value is 25. So 25 plus 5 and 25 minus 5. Correct? You can see here W by L of 1 is not W by L plus. This is actually minus now because it is less here in this particular case. Here it is plus. Maybe while doing the derivation we would have taken it as minus plus, but still make sure that it can be the other way also. Is that fine? I'll just make this minus. I'll just make this minus. Hello. In the chat box, come on, make it fast. Only one yes, Ishwaswini. How about others? Are you all sleeping? Just not for my sake, don't say yes. If you're not getting it, please ask me, sir, why this is so, why that is not so. Now, this is the time to learn. Of course, earlier I just thought, okay, half an hour is enough. Then I just realized, okay, these people may struggle. That's why I just opened it till the entire night. You have to wake up. Unless you get the answer, you should not go to sleep. That should be the what interest. Even though these are all small topics, but these are the things which will make you pakka and then go deep into the concepts. Is it done? Okay, let us now, okay, once we know what is, there is a different values of ID1, ID2, naturally VD1, VD2 will differ. What is VD1, Ayush? ID1, RD, RD1 of course. What is VDD, VD2? So this is 0.9 minus 0.8 milli multiplied by, how much was RD1? RD1, how much is 800, correct? 800, and this is 0.9 plus, sorry, this is again minus 1.2 milli multiplied by 800. Can you give me what is VD1, VD2s? .26 volt minus 0.06 volt. How much is V output offset? VD2 minus VD1, because you usually take it as this minus this, no? So it is now minus 0.06 minus 0.26. Is it not minus 0.32? You have to say very exactly, specifically minus 0.32. Is that fine? Come again. Nahi bhaiya. This is the output offset voltage that is available. To overcome this, I need to apply the input offset voltage, which is due to the change in WL, is given by VOV by 2 delta W by L by WL. How much is this now? 0.632 by 2 multiplied by, how much is this delta W by L? It is 10 by 25. Okay? Is it 10 by 25? Yes. It is 126 millivolt. If I apply a voltage which is plus 126 millivolt, by grounding this, you can able to nullify the offset voltage. So you're telling this is half. No. What we said was, no, I think you got confused with that half. How that off we got it is, you had this delta ID, no? Change in current. Change in current on one side of the transistor divided by GM is equal to half of the input offset voltage. Getting the point? Because this change in current is happening at only one side. You'll be having the identical change on the other side also, because we have assumed the changes in these two exactly equal. Are you getting the point? Hello. And okay, how many of you have the doubt in this? So in the textbook he just gives, okay, let me just open the textbook and also show you that how it is given in the textbook, and let me just show you that also. Okay, I'll just show you, okay, how the things will go in the textbook, and then 1 second. You can see it's hardly one line in the textbook that is given. You may have to just read between the lines to just understand, okay, what it is. So I'm just trying to give the same thing, doing simulations and then explaining the things. Just give me one time. Oh, this is offset, no? This is, let me just give me one more time. Control F. I'm looking at offset. This. It's too far away. Let me just go down here. Which is the chapter for your operational amplifier? Number. Okay, differential and somewhere here. Okay. I hope it is visible. Is it visible? Okay, let me just show you this. One second. Okay, this is the next edition. Just let me open the previous edition. In the 6th edition they have made it straightforward. Matlab, okay, they're not given that explanation. Maybe in the 5th edition. Usually the older editions will be in detail. I'll just show you that also. Now don't think that okay, these are topics just for the examination purpose. If you want to clearly get the concept, you may have to slightly go deeper into the subject and then try to learn. Where is differential amplifier? Just let me just show you this. Okay, somebody pick the question, sorry, chapter number. Okay, and I'm here. Okay, this is chapter number 7. Let me go to chapter number 7. Okay, this is 720, page number 720. Am I there at 720? This is still 533. Okay, I'm here. Almost there. Okay, Ayush, can you read this? Ayush, just read this. You got dividing the current, dividing. Okay, the increment, the current increment is I by 2 delta WL divided by 2 WL. Is that fine? Just read what is there. Next line. Dividing the current increment this by GM gives half the input offset voltage due to the mismatch in WL. All of you read this again. Just read it. Dividing the current increment. Dividing the current increment, he has given the expression by GM gives half the input offset voltage of the input offset voltage. That's what I'm trying to show you here. This is the delta ID. Dividing it by GM will give you half the input offset voltage. Okay? That's how you're reading that sentence. That's how you should read that sentence. So that results in, so when we actually did the derivation in the last of videos, can you see from this only we could able to get input offset voltage is given by half of the overdrive voltage multiplied by this ratio. Done? So in order to overcome this much amount of output offset voltage, I need to apply this much amount of input offset voltage for the differential amplifier. Correct? Okay, we'll just go to one of the simulation and then try to show you the same thing. I'll just share this. Okay, can you tell me what are these RDs? RD was 800, no? Let me just make this. Let us verify all the parameters. Is it 800? Kitna? How about WL of 2? 300. Okay, 300 is W. How about this? 200, done. 200. And then how much was the current was 2 milliampere, correct? Let me make the voltage as 0 so that I can make out what is the output offset voltage. Done? Okay? No. First, let us find what is output offset. Let us find what is ID1, ID2. It was supposed to be 800 microampere and 1.2 milliampere, no? Okay, let me make that. Okay, let me make it both of them as same. This is actually NMOS. This is also NMOS. This is actually for a different values of VTU. Let me just make this just NMOS. And this is 0.5, no? Was it 0.5? Okay, let me totally remove this. If F5 is removing this, am I done? Let me just remove this also. This is not required. Sorry. Is it 0.4? In nahi bhaiya, 0.5. How much is VTO? 0.5. Of course, VTO is nowhere coming in the. Of course, we didn't consider, but here VTO is 0.5. Sorry, 0.5. Just seen the problem. 0.5. That's why I made it. This is fine. Okay. Are we set with the values of RDs and WBL and KPs and VTOs? With the input voltage as 0, both are grounded. V02 minus V01 happens to be the what? No, no, no. What is that? How do you define V02 minus V01? It is called as output offset voltage. Okay. I will run it. First, let me see what is. Can you directly see V02 minus V01 is almost. See here how much. Where is the current? Where is this? Okay, it's here down. Can you see it is minus 320 millivolt? Was it not exactly same here? See here. Is it not minus 320 millivolt? What I want to show you is that because of this mismatch in WBL, when you ground both the inputs, you have a differential output voltage which is minus 320 millivolt. Why it is so? Because the current flowing in this MOSFET, let me just show you this also. Okay, can you see here it is 800 microampere? Where is this? See this? How about this? It should be 1.2. Can you see it's 1.2 milliampere? Is it not the value that we calculated? Where is that? This one? Here? It was supposed to be 1 milliampere, but there is a delta of 0.2. Here it is minus, here it is plus. Okay, now we'll just go back to simulation. How do we uh, overcome this output offset voltage now? Applying input offset voltage exactly in the opposite polarity with the desired value. How much is the desired value? 126 millivolts. Since the output offset voltage is negative, I have to apply a positive output offset voltage. Sorry, input offset voltage. Done. I have applied 126 millivolt. Say run. Now, okay, I have applied it. Just a minute. Okay, why it is not stopping something? Give me 1 minute. I don't know why it is. It is still simulating. This run, I'm unable to run it. Let me see just why it is happening. So let me close it once. Let me open it again. Which is that? Offset wala. Okay, this is fine. So this is 200. I just want to verify myself. Okay, since I applied the input offset voltage, V02 minus V01 has to be 0. Close to. Oh, minus 320. Why it is still minus 320? Have I not applied? This is 126. This is 200. Sorry. This is 300. Oh, some issue is there. Why it is not stopping? Save. Give me a minute time. Close this entirely. Okay. Let me do dot op of this. Okay, how much is input offset voltage? VOV by 2. Let me first make this 0 and then try to find out. This is 0. Let me run. This is 0.26. This is minus 0.26. Can you see this? Okay, this is what we expected. And can we find what is VOV? How much was VOV there? Can you see it was how much was VOV? Was it 0.62? Can you see this VDS hat is there? Is that fine? Hello. Okay. Then let us find what is this. This was supposed to be minus 320. Okay, let me do dot tran. Dot tran is there. From here to here it is minus 320. This is your output offset voltage. Let me make this as how much? 126 milli. 126 milli is done. Save it, run. Can you see it's almost there? 0. Can you see it is 9.32? 9.32. Of course, we might have missed out few fractions here. Suppose instead of making what you can do is, if you want to exactly make it 0, you can just sweep it. So what do I do? So instead of making it exactly 136, what I'll do is I will just make a DC sweep to get the exact value. What is this? VIPOS linear sweep from 0 to maybe 150 millivolt, 150 milli with an increment of 1 milli. Say run. Can you see, is this increasing? Just have a look at this vertical voltage. When this is 0, how much was the offset voltage? How much is offset? Is it there? See here. So what I'll do, I'll just keep moving my input offset voltage. I'm increasing. Can you see when I'm increasing, is this reducing? Output offset voltage is reducing. When you applied 19 millivolt as your input offset voltage, it has reduced from minus 320 to this. If you are increasing, you can see is your output offset voltage keep reducing. At some point it will become 0. This should become 0. Can you see is that is becoming 0 at some point? As per simulation, it is coming out to be 0 at, let me zoom it. Are you there? How much is this? 129 millivolt. To be exactly as per simulation. As per calculation, it was 126 millivolt. Done? Now, of course, we could able to exactly zero down onto the output offset voltage by sweeping the input voltage. Because if you vary this, the output voltage, output offset voltage is going to change. Done? Come again. That's what output offset voltage will become 0 when you are applying an appropriate polarity input offset voltage of certain magnitude. Okay. So on this line you may have to do it for other two combination. See this one. Here W value is same. Am I correct? How much is RDs? Can you see how much is delta VTO? See, before that we need to find out what is that average VTO. How much is 0.55 plus 0.45 divided by 2? It's hardly 0.5. Hello. So now that's what actually what happens is, let me just show you that when you're learning the design, when you're learning the theory design, let me just when you're learning the theory design, it's like learning the dots, correct? Only when you actually do the design, then only you know, okay, how to connect the thing, whether to connect it like this or whether to connect it like this. Of course you'll be simply knowing the equations. Only when you actually do the designs, so then only you get to know, okay, if I connect the known things, you can get a proper figure. Otherwise it will be totally random. You may be knowing n number of equations, when to use, why to use, all those things are very crucial. Getting the point? So what we have is VTO1 is equal to 0.55 volt, VTO2 is equal to 0.45 volt. But in the theory, what did you learn? You learn VTO1 is equal to VTO plus or minus delta by, okay, half of delta VTO, and VTO2 is VTO minus a plus. If this is plus, then this is minus. Okay, sorry, half delta VTO. Now the question is, what is this delta VTO? For that you need to get it from this. Is this VTO is equal to 0.55 plus 0.45 by 2, which is equal to 0.5 volt? Can I write VTO1 is equal to 0.5 plus 0.05? VTO2 is equal to 0.5 minus of 0.05 volt. So this VTO is equal to 0.5 volt, then half of delta VTO is 0.05 volt. Then what is VTO? Sorry, delta VTO? It is 0.1 volt. Correct? Okay, how do you get that delta VTO? Just the difference of these two. Difference of these two is actually 0.1 volt, no? Now the question is, uh, of course you have to find what is VD1 and VD2s. Correct? Or what is VD1, VD2? It's actually, okay, it is VDD minus ID1 into RD, VD2, sorry, VDD minus ID2 into RD. Of course RD1, RD2 both are same. What is ID1, ID2? Of course, while deriving this, we again found one delta ID. Correct? What was delta ID in the last, okay, when we actually derived it? Was it not this was delta ID? This one? Where is that? Okay, here. Is this not your delta ID? Sorry, is this not delta ID because of VTO change? This is this is your yesterday's derivation in the last video. See here, I by 2 into delta VTO by VOV is the change in the current due to change in VTO. If there is no change in VTO, how much is the change? There is no change. So now shall I write delta ID is equal to I by 2 delta VTO by VOV. Correct? How much is delta? How much is I by 2? 1 milliampere. How much is delta VTO? 100 millivolt. How much is VOV? That I need to calculate for these specifications. How much is VOV now? It is again under root of 2ID Kp W by L. Okay, let me just find out. Thank you. Is it 2 milliampere? This is 200 micro. How much is W bell for this given problem? I think W bell is 150 now for this problem. This okay. 15. This comes to be 0.832 na. Hello. 0.8816 volt. Now this is 816 millivolt. You know what is delta ID? Done? Oh, give me how much is delta ID? Come on. How much is the delta ID? Hello. 1.2 to what? 1.2 to what, man? 1 milli divided by 100 by 816. 100 by 16 how much? ಎಷ್ಟರಪ್ಪ ಇದು 0.122 milli, that is 122 microampere, correct? This is delta ID. What are you looking at? What are you looking at? ID1 is equal to I by 2 plus or minus half of ID, delta ID, correct? Am I correct? Okay, this is it half or full? Okay, this is the full ID. So this is the change in current on one side. So change in current is full delta ID. It is I by 2 minus or plus delta ID, because we consider on only one side. How much is this plus or minus ID1? So for is this corresponding to VTO1? This is VTO2, which is what is the value of VTO1? It is 0.55. This is 0.45. So shall I take minus or plus for this? If the VTO is more, does the current increase or decreases? Huh? It decreases. If the value of VTO is more, the current decreases, correct? So it is now 1 milliampere minus how much? 0.122 milliampere. It is 1 milliampere plus how much? 122. Okay, 0.122 milliampere. For which one? Oh no, bhaiya, plus. It's not plus, it's actually minus, because VTO more means it's going to reduce the value of ID, no? See, VGS minus VTO. ये बढ़ता है तो ये पूरा ID will come down, no? So that's why it's negative. Shall you do the simulation, then try to see out how much? Now for this I need to have different what is that, model files. For that I'll just okay, I need to have different model files. How do I do? I'll make this NMOS 1. I'll make this NMOS 2 here. I will copy this. I'll paste it here. Let me make it as NMOS 1 here. What is NMOS 1 VTO? 0.55. Okay, how about NMOS 2 VTO? 0.45. This is almost 2. Done. W bells, sorry, this one 500. Correct. How about this? 500. And let me make this 0 for the time being. Let us find the output offset voltage. Let me see the current. Is the W bells? Wait, I have to change the W bells. How much is W bell? 150 or 15, no? Okay. It is again 150 U. Okay, let me run it now. How much was my delta VTO? I think we didn't find. Okay, what is VD1, VD2? We are still yet to find, no? Okay, we are getting how much? Any? What is VD1, VD2? VD1 is VDD minus ID1 RD, VDD minus ID2 RD. Give me how much is VD1, VD2. Let me just see from here how much is VD1. Where is VD1? One of the value is 461 millivolt. Other one is 338. Okay, 338.8 millivolt. The difference is V02 minus V01. V02 minus V01 is 120, minus 120 millivolt, or minus 122. VD2 minus VD1 is minus 122. Are we getting it as per theoretical? See how close it is to. We are not doing something, okay, which is not verifiable. Everything is verifiable. Now to overcome this minus 122, how much you have to apply? How much you have to apply? Delta VTO. How much is delta VTO? 0.1. Since the voltage is negative, since your what is that, offset voltage is negative, you need to apply simply positive 100 millivolt. Correct? 100 milli. Run it. Can you see it's almost becoming 0? Can you see this? V02 minus V01 is 0 hai? Perfect. See? This is the beauty of simulation and then comparing that with your circuits. Whatever being told in the class or in the theory has to be performed and verified using simulation so that you'll have a hold. Otherwise, you'll just think, okay, sir is telling something, it may come or not come. It's not so. How about the last one? Just have a look at this. I'll just leave it as open so that you can just think in these 2 days and then come up with the answers. What is there here? Oh, 1 second. It's not camera. It is this. Is it not visible? No, this one. Last one. What is that there? What is the difference between the above 3 and the last one? There is a mismatch in both. It is possible, no? It is not that a mismatch is only in W bell, only RD, only VTO. So now I am trying to introduce error in 2. It is possible to error in all the 3. In such case, how to overcome? See now, in this case, W bell of this is less, this is more. Correct? This will end up with some offset voltage. This will also end up with some offset voltage. So overall, we are supposed to apply an input offset voltage which will nullify both the offset voltages. Correct? Let me just go back to your textbook thing and then show you this, not this, maybe this one. Okay, let me show you this. Can you see this here? Finally, we note that since the three sources of offset voltage are not correlated, an estimate of the input offset voltage can be found something like this. This is when you have a mismatch in all the three. So it is like, okay, RMS, root mean square. What is the first one, Ayush? If there is an error in delta RD, sorry, if there is an error in RD, how do you nullify it? Correct? How about this? This one? Perfect. So for the last problem, we may have to take square root of this plus this term. Not the second. Sorry. Yeah. VTO is same. We have to take the first two because there is no deviation in your delta VT. Of course, even if you consider it will be 0, it will happen to be this plus this. Getting the point? Okay, for that you need to find what is delta RD, delta WBL, and of course VOV. VO will be common. Hope people can able to get a solution for this. So I'll just leave it to you people. If you are interested, do it. Otherwise, just forget. If it is asked in the SE or test or somewhere, you just leave it. Don't attempt. Is your thing? If you attempt, I'll be so happy by just evaluating your answers. So you are also interested, something like that. So I'm just looking at. You cannot. Who is this? Pramod. I know that okay, it cannot be so easily found. You may have to just spend some time. How much is VOV? All those things you have to find. No. How much is VOV here? VOV. That you just verify. No, don't give me the answer. Verify it using your simulation and then you just tell me. So don't give me some number. Correct? First do the simulation, convince yourself, then only you give me the answer. Don't give some okay 0.5, 0.3, 0.7, something like that. Make sure that it is working fine. Okay, what we'll do is, this is about the offset voltage. You can see even though this is a very simple thing, lot of concepts involved, you may have to fill in each and everything, means you need to work out. So I can show you some of the answers, how casually you are giving it. So I'm not satisfied with your efforts. Okay, any questions on this? Sir, is it so tough? Will you be asking anything such type of questions in the examination? That's your major doubt. I think all of you have that thing running in your mind, no? Just say yes. So can we do this? What is this? Okay, just look into this later. Okay, how many of you taken the AD kit so far? I just want you people to unmute and then say. Of course, you have given the names. How many of you opened it? You have taken it fine. When did you took it? Who is this? Who is this? Okay, when did you took it? What did you do with that? Taking is fine. After that, what? Did you actually open and measured something? Did you are you curious enough to just okay, turn on that to connect it to your system and all those things? From where you will get it? Will you go to buy market and get it? I said it. No, it's available in the net. You need to download simply. Huh? What is this? Now, taking the kits from the lab is of no use unless you start using it. I said it, waveform is an open source, you can easily download. The biggest problem with all of you is that you people never ask me any questions. Even I ask 1,000 questions, there's not a single question from your side. Okay, who else? Okay, when you're planning to download that, movies will be downloaded immediately, not these softwares. Who is next? Other batch. Hello. I'll just read out the names. Simply taking the AD kit is of no use. Do you know what is the cost of AD kit? It's 30,000. If you're not using it, give it to me. I'll just give it to some student who are eager to use it. Rupashri, Nivedita. Hello. Rupashri, Nivedita, Shravani, Tanuja, and Ritunand. Ritu Anand, sorry. None of you are there? I know that you have taken. What you have done next? Puja Mat. Then installation doesn't take more than 5 minutes. Have you connected any circuit? Oh, you made a muhurta today. Who is okay? Yashaswini, Bhagyashri, Lohit, Sunil. Of course, all of you will give the same answer. Sir, we have downloaded this and then we will do it today. I know, okay, all of you will do say the same. Is there anybody who has tried other than Navda? In interest, but I'll just take you the kits. So I'll ask you to come to examination directly so that I can fail all of you. This is the interest shown by each one of you. Deepika, Akshata, Sonia, and Sonu Bhatt. What is the status? When did you took it? Yesterday was full holiday. Utilize the time effectively. Huh? Come again? It was there with one of the student, no? That student can actually start. ಏನು ರಜಾ ಬಂದ್ರೆ ಮಜಾ ಮಾಡಕ್ ಹೋಗ್ತಿದ್ರು ಎಲ್ಲರೂ? No, spend some time. You're all half cooked now. If you go this way, all of you will just come out, bounce like anything. Don't of course waste your leisure time. Effectively utilize it. There is a holiday. I can see all of you are just okay going out. ಏನು ಕಲ್ತಿಲ್ಲ ಆಗ್ಲೇ ಓಡಾಡ್ತಾ ಇದ್ದೀರಾ? How many are yet to take it? How many of you are from Tumkur? You have not yet taken the AD kit? I'll call a meeting of your parents. ನಾವೇನು ಕಳ್ಸಕ್ಕೆ ಹೋದ್ರೆ ಕಲಿಯೋದಿಲ್ವಲ್ಲ ನೀವು? So by another 2 days, if of course I'll just give you till Monday evening. If you're not doing all the experiment that I already posted and then few more I'm going to post it. If you're not doing it, so I will just make all of you NE for this test, for this ACE. The other students who are there out of station, so of course you may have to come. Okay, when I ask you two people to come, if at all if you want to take the exam, I'll just again make that very clear. I'm not making it mandatory. When did I ask you to come? For practice and so on so. Let me just find out the timings. Does anybody has 8th Feb? If you want, you can come. If you don't want, you can be there at home. So there will be no test or exams will be given to you people. Those are not coming for practice because we know how much you're learning. ಮನೆಗೆ ತಗೊಂಡೋದ ಸುಮ್ಮನೆ ಕೂತಿದ್ದೀರಾ? Okay, anything to be discussed? Hello. 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 Why there are still so many absentees? So we should have 54 plus number. Of course, diploma students. I don't know if diploma students are getting in now. That's fine. But regular students, they will find it very difficult. Maybe let me just give you this question to you people now. So maybe on the same topic. So I want you, all of you, to solve and tell me what is the value. Let me just open this. I have the differential amplifier. You are supposed to find what is the offset voltages. This is simply make W1. Give me this. Of course, assume Kp is equal to, or I is equal to 2 milliampere. VTO 0.4. Let me make it VTO 0.4. VTO1 is equal to VTO2 is equal to 0.4. Who is 25? 25. Who is 25? What is the average W bell? W bell. Now we are given. No, no, we have 35. How much is delta W bell? 10 now. How? Okay, delta W is 100. So delta W bell is 10. Okay, fine. Find out what is ID1. Okay, that's fine. ID1, ID2s. Fine. Fine, fine. ಆಯ್ತಾಯ್ತು ಇನ್ನೊಂದು 2 ನಿಮಿಷ. Okay, once you're done with it, you just share me the answers. So AD kit maybe around do people require the AD kit introduction, okay, how to use it, or will you manage it? If you want, I'll just meet you at 12 o'clock. Okay, let me just meet after the class, how to use it and all those stuff. We'll meet at 12. Done? Thank you.